All right, section 17.2, part 1. We are going to look at the IUPAC names and drawing structural formulas for groups of compounds called alkanes and alkynes. First, though, we're going to talk about functional groups. We take organic compounds, those carbon-based compounds, and put them into classes or families by what we call their functional groups. Functional groups are groups of specific atoms. These compounds that contain the same functional group have similar physical and chemical properties. So we're going to be learning about a lot of different functional groups. We've started out with alkanes, and that was what we talked about the last few days. Identifying functional groups allows us to classify them by their structure, to name them, predict reactions, and draw structures. So being able to identify different functional groups is important. Two more functional groups we're going to talk about today are alkenes and alkynes. Alkenes and alkynes are what we term unsaturated hydrocarbons because they contain double and triple bonds. Having double and triple bonds lessens the number of hydrogens available. So the first one we have is ethene. Ethene it's the simplest alkene. Notice the ene ending. The ene ending indicates a double bond. So we have a double bond between two carbons, and then we just have, notice, two hydrogens on the end instead of three. Then we have ethyne with two carbons again, but a triple bond between. So ethyne, the yne ending, indicates a triple bond. Notice here we only have one carbon on each end rather than the three we had in alkanes. Now, I wouldn't recommend writing all this down because we're going to get into functional groups more as we go through the chapter, but I just wanted to point out some of the different functional groups. Alkenes indicates we have a double bond somewhere. Alkynes indicates we have a triple bond somewhere. Alcohol. Somewhere on the compound we have an OH group. So here is ethanol or ethyl alcohol. Here's the two compounds, which is ethyl, and there's the OH, the alcohol group. So we have ethers, which contain just an oxygen in the middle of something. Aldehydes, a carbon double bonded to an oxygen and another hydrogen. Ketones, a carbon with a double bonded oxygen. So we've got the simplest ketone is acetone, so you may have heard of that one before. Other functional groups are carboxylic acids. Those are acid groups. That makes ethanoic acid or acetic acid, which is found in vinegar. We have esters, amines, which is a nitrogen group, and amides, which is a double bonded oxygen and a nitrogen group. So we've got lots of different functional groups, and we'll be talking about all of them as we move through the chapter. All right, now we'll get into naming alkenes and alkynes. The naming system for alkenes and alkynes is very similar to naming alkanes. We just include the double or triple bond that's in the longest chain. That's the parent chain. So the parent chain always contains the double or triple bond. You number the chain so that the double or triple bond has the lowest possible number, and we end it in ene and yne, depending on if we have a double bond for ene, a triple bond for a yne. So here we have some functional groups, comparing them. We have ethane, 2 carbons, single bond, ethene, 2 carbons, double bond, and ethyne, 2 carbons, triple bond. So then we have propane with 3 carbons. Here we have propene with 2 carbon double bonds there, and propyne with a triple bond. So we can compare the 3 different in name endings. So now we'll learn to write the name for this compound, looking at the different functional groups, the substituent groups, and the parent chain. So the first thing we're going to do is find the longest carbon chain that contains the double bond. So we see here we have 1, 2, 3, 4, 5 carbons. We could come here and count 1, 2, 3, 4, 5 carbons. Either way, that's the longest chain. 5 is penta, so it's pentene. That's the parent chain. Step 2 is to number the chain, starting from the end nearest the bond, the double bond. So the bond, we have to give the location of the double bond. So I number them. I'm gonna number it backwards: 1, 2, 3, 4, 5. That way, a double bond is after carbon number 2. So then we name it 2-pentene. And then you do the substituent groups the same way as we did with alkanes. So on carbon number 4, there's the methyl substituent group. So we say 4-methyl in front of the 2-pentene. So let's work on another example here, looking at these bonds. I notice I have a double bond, so that's going to be an ENE ending. I'm going to count my carbons. I have 1, 2, 3, 4, 5 carbons again. So 5 carbons, the parent chain is pentene. And I'm going to number my carbons. I'm going to start at this end numbering the carbons. So I've got 1, 2, 3, 4, and 5. The double bond is after carbon number 1, so I'm going to name it 1-pentene. And then I've got this bromo substituent group that is on carbon number 1 as well. So I'm going to name it 1-bromo 1-pentene. Drawing them is very similar. We'll just draw the parent chain first and then come back in and add substituent groups and add hydrogens. So we see here we have the hexyne naming there. So hexa is 6. So we're going to make 6 carbons. I'm going to number my carbons. And I see that I have a triple bond after carbon number 3. So the hexyne is after the triple bond is after carbon number 3. So I'm going to put the triple bond right here. Then I'm going to come back and I see my substituent group is 1-chloro. So somewhere on the first carbon, I'm going to put a chloro group. And then now I'm going to add in my hydrogens. First carbon already has 2 bonds, so it needs 2 hydrogens. This guy needs 2 hydrogens. The 3 and 4 don't need any hydrogens. 5 needs 2 hydrogens. And 6 needs 3. So that would be the 1-chloro 3-hexyne. So as you can see, naming the alkenes and alkynes is very similar to the first system, the alkane system.